The game I chose is Yahtzee. The goal of Yahtzee is to roll 5 dice and get scoring combinations that lead to the highest total score. For this situation, we are going to be looking at rolling 3 dice first and getting ones on all 3 dice, and then rolling the other 2 dice and trying to get a pair to get either a Yahtzee or a full house. To find out the probability of rolling 3 ones on the first 3 dice, we need to multiply 1 over 6 times 1 over 6 times 1 over 6. This will give us 1 over 216. Next, we're going to look at the other 2 dice, which we need to roll a pair on. The probability of this is 6 over 36, as there are 6 ways of getting a pair and 36 total outcomes when rolling these 2 dice. So to find out the probability of getting a full house or a Yahtzee, we need to multiply these 2 probabilities, which give us the final theoretical probability of 1 over 1,296. Now, after this, we are going to move on to the probabilities of getting a Yahtzee or a full house, now given that we have already rolled the 3 ones. For the current situation, there are 3 dice rolled as ones and 2 that are not. Our objective is to either get a full house or a Yahtzee. To get a Yahtzee, we will need to roll a pair of ones, and to get a full house, we will need to roll any pair of 2s, 3s, 4s, 5s, or 6s. This is conditional probability, as we are now trying to find out the probability of getting a Yahtzee or a full house after there have already been 3 ones rolled. To find the theoretical probability, first we need to multiply 6 times 6 to find the total different outcomes, which equals 36. Next, we need to look at the possible ways of getting doubles. These are 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. So therefore there are 6 different possibilities of getting doubles. So now, the probability of getting a full house or a Yahtzee, knowing that we already have 3 dice as ones, equals 6 over 36, or 1 over 6. Next, I'm going to ask 3 people what they think the subjective probability is. And for this, I have made a scale. So for very unlikely, it would be 0 to 4 times out of 20 that there would be a pair. For unlikely, it is 5 to 9 times out of 20 that there would be a pair. For 50-50 chance, it would be 10 out of 20 there would be a pair. Likely, 11 to 15 times out of 20 there would be a pair. And very likely, 16 to 20 times there would be a pair. Now on to the 3 people I asked for subjective probability. First, I asked my mum, who said unlikely. Next, I asked my sister, who just like my mum, said unlikely. And then finally, I asked my friend Josh, who like the other 2, said unlikely. For the experimental probability, I rolled the other 2 dice 20 times. Within those 22 times, 5 times there were pairs, and on roll 4, 5, 10, 13, and 19. So therefore, the experimental probability of getting a Yahtzee or a full house, given that there was the 3 ones, is 5 over 20, or 1 over 4. Now we are going to compare the 3 types of probabilities. First off, the experimental probability was 5 over 20, or 25%. Next, the subjective probability was 5 over 20, or 25%, to 9 over 20, or 45%, as that is what the subjective probability for unlikely was. Finally, the theoretical probability was 6 over 36, or 16.67%. As the experimental probability was 25%, it lies within the subjective probability of 25 to 45%. The experimental and subjective probabilities are both higher than the theoretical probability. Although theoretical probability is what should happen, the experimental probability is all about chance. If there were more trials done, the experimental probability would become closer to the theoretical, but because there were only 20 trials conducted, they were not too close.